So we'll start with some questions that I think you can answer, and then we'll get into some that lead into the lesson more specifically. So what was f of x if f prime of x is... So I'm going to give you a table, basically, where I tell you what f prime is, and you need to be able to think backwards and figure out what f is. So kind of a backwards Jeopardy type question here. So if f prime is 3x squared, if f prime is 5, f prime is 3x to the fourth minus 5x squared plus x, and if f prime is 4 cosine x. Now let's do the first one together, then I'll leave you a few minutes to work on the rest. So thinking backwards, this is where thinking backwards is most of what we do this semester, which means you've got to know the derivative rules well enough forward so that you can go backwards. This is driving in reverse. I think I've made that analogy before. Like, the better you can drive forward, the easier it is to drive in reverse. It's still not easy to drive in reverse. You still got to be careful, go slow, constantly check your mirrors or your backup camera or whatever. But you definitely have to be able to drive forward before you can go in reverse. Most of you are fine at driving forward, but if by driving forward I mean taking derivatives. So if you'll be careful, you're fine to take antiderivatives. That's what we're doing today, going backwards, antiderivatives. Having said all that, if f prime is 3x squared, what was f of x?
X cubed.
X cubed. Yeah, yes and no. Is there anything else x cubed could have been, or not x cubed, is there anything else f of x could have been?
Could there have been a constant that disappeared?
Yeah, it could have had a constant on there, because the constant would disappear when we take the derivative, right? The derivative 7, 0. So we don't really know if it was x cubed or x cubed plus 7 or x cubed minus 12 pi. Like, who knows? We don't really know. There's no way to know, at least yet, what that constant was. And so to handle that, when we take antiderivatives, we're always going to have a plus c at the end, because we don't really know. There could have been a constant that went away when we took its derivative. All right, so I'm going to leave you a couple minutes to try B, C, and D. So think backwards. When you get your answer, don't forget the plus C. So there's the answers to those. Again, don't forget the plus C. A little bit later, we'll talk about sometimes you can figure out the plus C. Other times you just have to leave the plus C on there. All right, what you just did are antiderivatives. And hey, if you struggled with some of them, that's fine, because we hadn't even done the lesson yet. So if you got a few of them right, then any of them you got right means you're ahead of the game. So if you struggled with some, fine. If you're able to figure out some, all the better. Going backwards is what we're doing today. So taking an underderivative. And again, which means you've got to know those forward rules well enough to be able to go backwards. We'll talk about some of the rules, but the rules basically boil down to go backwards. Like, most people don't memorize the rules. They know the forward rules well enough to just kind of figure it out. I think the analogy with driving backwards is the same. Like, in theory, well, if you turn the wheel one way, the car goes a certain way, and it's backward. Who cares? Like, you know how to drive forward, you can figure it out going backwards. That's kind of the same thing today. So with polynomials, it's the power rule in reverse. I think we all know the power rule, but let's review it. That way we can go backwards with it in a moment. So take the derivative of x to the n. So bring the n down front, decrease the power by 1. And right, that d dx means take a derivative. Derivative, yes. The integral, or the antiderivative, take an antiderivative. Let's pause here for a second, because up till now that symbol really meant something else. What is that symbol usually? What did it mean all of last week? Find the area. And that's kind of the big deal with calculus, is the area and the antiderivative are sort of the same. We'll make that connection more later, but for now, just yes, it means find the area, but it also means take an antiderivative. And it kind of depends on the problem as to which one you do. It also, if there's limits there, like if there aren't any limits, then I can't take an area, right? Because I don't know where to start and stop. So if there's no limits there, it's definitely take an antiderivative, because the area from where to where, it doesn't tell me. So with no limits, it's definitely an antiderivative. Beyond that, we'll talk more later as to whether you're thinking area or thinking antiderivative. All right, anybody want to take a stab at this one?
No.
How do I underderivative? X to the n is sitting there. What's the power going to be?
N plus 1.
N plus 1. So I know the power is going to be n plus 1. I got to go up a power. But I need a coefficient fix there. If I take this derivative, I will get back to x to the n, so that's right, but I'd have n plus 1 out front. So in order to fix that, let's divide by n plus 1. And then don't forget the plus c. So increase the power by 1. There's our rule kind of written out. Divide by the new power. Increase the power by 1 and divide by the new power. And maybe that helps make sense of C from the warm-up. 3x to the fourth, so we increase the power by 1 and divide by the new power. 5x squared, increase the power by 1, divide by the new power. X, increase the power by 1, divide by the new power. So it makes things go a little faster if you know the backwards rule. But again, some people don't really ever memorize that rule. They just figure it out as they go. All right, let's try some of the harder ones. Do you remember what you had to do first when we were first? This probably not. It's been too long. But when we first did derivatives, sometimes it was better if you did algebra first, because then you didn't have to do the quotient rule or the product rule or anything crazy. You know, just to spend a little time on the algebra and makes life easier. It's the same thing with antiderivatives. And there's not really an antiderivative quotient rule or product rule. So there's not a way around this. You kind of have to do the algebra first. So I'm going to rewrite square root of x as x to the 1/2. Then maybe this is overkill, but they're both over x to the 1/2. Right, I can split that fraction up like that. sort of unadd them. Still doing algebra. What's x over x to the 1/2? X to the first over x to the 1/2. X to the 1/2, right? Because you would subtract the powers, 1 minus 1/2. And what about 1 over x to the 1/2? Could I rewrite that with just a power, x to some power? X to the negative 1/2. Okay, all of that was algebra. We're going to do something new in pre-cal this year. We're going to give them an algebra test, basically, to help them decide which math class they should go in next year. It's going to have some stuff like this on there. It's like, if you can't do the algebra, the calculus isn't going to matter because you're going to get stuck on the algebra. You guys know that. Probably even still, most of your errors aren't really calculus errors. They're algebra mistakes. Like, I know the calculus, and my algebra lets me down. So you didn't need to know that, but we're trying to address that this year in pre-cal so they can make a choice on which class to take next year. Okay, now I'm ready to do the calculus. The algebra part's over. So the rule is increase the power by 1, divide by the new power. I got fractions, but the rule's still the same. So if I increase 1/2 by 1, what do I get? I start with a half, I add 1 to it, I get 3/2. Now I could divide by 3/2, but that's going to look weird, and I'm going to have to fix it anyway. What's the same thing as dividing by 3/2? Multiplying by what? 2/3. That's also one where people might just kind of figure it out. I know it's going to be 3/2, which means 2/3 need to be there so that everything cancels and I get back to x to the 1/2. Alright, if I start with negative 1/2 and add 1, that gets me to 1/2. And then I need to divide by the new power. So divide by 1/2, but that's the same thing as multiplying by 2. Or just figure out, well, I need a 2 there, so that 1/2 times 2 gets me back to 1. And then don't forget the plus c. So how we complicate these problems is basically on the algebra end of it. Like there's not much we can do to complicate the calculus side. Increase the power by 1, divide by the new power. So instead we mess with you on the algebra end of things. Like this. Find the antiderivative of 2x minus 3 squared. What do you think you should do first on that one? Foil it. So you try that. Foil it out and then do the calculus. So algebra first and then calculus. So I foiled first and then I up the power, divide by the new power. And yes, 12x squared over 2 would reduce, but that's a safe stop thing. So I just up the power, divide by 2, and leave it alone. So that's the power rule with a couple of algebra tricks thrown in there. All right, let's review some trig rules. No, I still have to know the trig. Let's see how much trig we remember. Uh-oh, are we okay back on this one? 9x. I mean, if you really want to prove it to yourself, it's like 9x to the 0. Most people don't think that. They just remember that the derivative of 9x is 9, so going backwards is 9x. All right, trig. Basically, this is just reviewing the trig. This isn't new information. It's just presented differently. Who has a derivative of cosine? sine. Now think very carefully on this one. Who has a derivative of sine? Negative cosine. So again with the negatives. But the rule is still the same. The derivative of sine is cosine. Derivative of cosine is negative sine. That's where that negative comes from. Okay, thinking backwards, which one of the trig functions had a derivative of secant squared? So find the antiderivative of secant squared. Very hesitantly, but yes, tangent. Tangent? Question mark. Yes, the derivative of tangent is secant squared. And you remember these all come in pairs. You know the first one, you can usually figure out the second one. The antiderivative of cosecant squared. That means who has a derivative of cosecant squared? Well, if tangent led to secant squared, cotangent, but it would need to be negative. And then the last one, it's almost easier to, we're just so used to driving forward. We know the answer is going to be secant. Do you remember what the derivative of secant was? Kind of going out of order on this one. Secant tangent. So you've got to know the trig rules well enough to recognize the answers to make a Jeopardy question out of it. If the answer is secant x tangent x, that meant the question was find the derivative of secant x. And I definitely don't have the second half memorized. I just look at the first side to switch everything. Whoops, dx. Find an antiderivative of cosecant cotangent. That would be negative cosecant x plus c. Oops, left off the plus c on the secant one as well. So let's put a few things together in an example here. Find the antiderivative of 5 sine x plus 3 dx. So there's the answer to example 3. Don't forget the plus c. Roman numeral 3, 3 of 3, so we're almost there. Solve a differential equation with an initial condition. That initial condition will help us find c. It's new words, but it's really not that big a deal. Let's do one. Let's say y prime equals 1 over x and y of 1 equals 0. Y prime equals 1 over x and y of 1 equals 0. The y prime, that's, again, some people are fine with that. Other people want to write it as dy dx. But I need to underivatize that. In fact, well, I'll just go through the formal steps, even though a lot of times you won't do this. I just separated the dy dx. dy dx is not a fraction. This comes up in our Facebook fun group once in a while. How to say this precisely. dy dx is not a fraction, but you can treat it like a fraction. And that's the simplest way to say it. dy dx represents a derivative, represents a slope. It's not a fraction, but you can kind of act like it is. And then to undo the derivatives, we'll take an integral. We'll antiderivative. So the antiderivative of 1 is just y. That's the easy side. And now the point of this problem, I'm going to rewrite that as x to the power. So I need the antiderivative of x to the negative 1. The antiderivative of x to the negative 1. Natalie? Wait a minute, I started this problem wrong. No wonder this isn't working right. This should be y prime equals 1 over x squared. This wasn't going to work otherwise. 1 over x squared, 1 over x squared, 1 over x squared, which is x to the negative 2. Now if you add 1, now this makes a lot more sense. What do we get if we add 1? X to the negative 1, and don't forget the plus c. So my answer is kind of 1 over x plus c. I say kind of because this initial condition, that's the fancy word for here's a point, and we can use the point to figure out what c is. So up until this Roman numeral, we would stop there and say, well, that's as good as we can get. But they told us that y of 1 equals 0, so if we need to translate that to a point, that means 1, 0 is the point. Right? X is 1, y is 0. So let's plug that in. Y is 0. X is 1. And then plus c. Man, I am off my game today. Big time. I've messed up. Do you know where I messed up? It's right back here. From here to here. I didn't think about the coefficient. I increased the power by 1, and then I was supposed to, after I increased the power by 1, divide by that new coefficient. So that should have made that negative. And I can follow my mistake back through here. Okay, that was a relatively easy mistake to fix. Not a good one to make, but not hard to fix. So 0 equals negative 1 plus c. C equals positive 1. So now my answer is negative 1 over x plus 1, because I figured out what c is. Goodness, that was brutal. 2 mistakes in one problem. Monday morning issues. Let's do one more. See if I can work this one without any issues. F double prime of x equals cosine of x. F prime of 0 equals 1. And f of 0 equals 4. Okay, so I'm starting with a second derivative. So how many times will I have to back up to get to the regular function? Twice. So I need to underivatize once, that'll give me f prime. Then I'll underivative another time, and that'll give me to f. So if I underivative once, you guys know you got to pay close attention today because I'm trying to mess up a lot. What's the antiderivative of cosine? Sine. Sort of. Plus c. You need the plus c on there. And I could back up again, but I don't want to back up yet because I can use this piece of information and figure out what c is. So f prime is 1, when x is 0. So it's helpful to find the c's as you go rather than to underivative twice, and then you got 2 c's to deal with. It can be done, but find them as you go. What's the sign of 0? Pre-cal experts, yes. So now I know that f prime of c is, or excuse me, f prime of x is sine of x plus 1. Now I need to go backwards one more step. What's the antiderivative of sine? Negative cosine. The antiderivative of 1 is x. And why am I not done yet? Plus c. And I'd like to know what c is. And they told us f of 0 is 4. So if I plug in, if I use that piece of information, so f is equal to 4, the y value is 4. When x is 0, negative cosine of 0 plus 0 plus c. What's the cosine of 0? Cosine of 0. Sine of 0 is 0. What's the cosine of 0? 1. Good. So negative 1 plus 0 plus c. So c is equal to 5. Not really done yet. I need to rewrite my final answer here. F of x, negative cosine of x plus 5. One minor thing in there that it's not wrong, it's just sometimes a little confusing. Each time we integrate, we use c, but the c's for the first derivative weren't the same as the c's for the second derivative. So if you can keep that straight, that's fine. If the second time through you're like, wait a minute, that's a different c, and you want to call it c2, that's fine too. Okay, because they're not the same c. But you sort of resolve the first c before you introduce the second c. So you could, if you can keep them straight, fine. If you want to call them different things, also okay. All right, page 251, 11 through 39, every other odd. And again, if you're calc chatting, this is section 4.1. Calc chat needs the section, not the page number. This is the last of the new stuff of what's on the test. Tomorrow we'll have a review, and then Wednesday we'll test.